This is an introduction to interval notation for Algebra 2. Basically, when you have something like this, that means all numbers in between -3, including -3, this means including -3, up to 5, but not including 5. So this is called, this is more set notation, and this is interval notation. So if you include the -3, you use a closed bracket, which we're including because of the equal sign. And if you don't include the 5 here, then that's called open interval. So that's open, closed. That means we can get to, like for example on the graph here, we can get to 4.9999999, but it will never get to 5. Okay, so very close to 5 without getting to it, but it can equal 3. So what we do is we close the circle on -3, and we have an open circle on 5. Okay, let's do some more problems here. We have an inequality that says that x is greater than 2. So I'm going to go ahead and draw the number line here. And when I'm drawing it, I'm not going to draw all the numbers. I'm going to go ahead and put my 0. And somewhere here is about 2. So we know that it's all numbers bigger than 2. So 2.000000001 is bigger than 2. But it can't, so we have to include all of that. So we're going to leave an open circle on the 2. Because we can get very close to 2. So you can't start at 3. You have to start as close as you can to 2. And then this continues on, because we can do all numbers. We can, 1,000,000 is bigger than 2. So you just color that in and put an arrow. Okay, that's how you do the graph in one dimension. And so the interval notation is, we start with 2, it's open interval, comma, and we go to infinity. Now you can never reach infinity. You never can touch infinity. So that is also an open, or parentheses. You just put parentheses there. Alright? Let me squeeze in another one on this page, and let's do one that says x is less than or equal to 3. Alright? So basically I'm going to go ahead and draw it here. I'm going to get a little smaller here. This is actually x is less than or equal to 3. So I'm going to put my 0 just for a placeholder thing and put my 3 there. So it can equal 3. All numbers, 3 is less than or equal to 3. So I do my, draw my circle and I close it in because it can equal 3. And this means all numbers less than or equal to 3. So I'm going to draw this way. All these numbers, all the way to -infinity. This is -infinity. I like to draw infinity. Alright, -infinity. And this side goes to infinity. And for interval notation, that means I'm going to start with -infinity. I'm starting here. And I comma 3. Now since it can equal 3, you're going to put a closed bracket here. So we close it up and use a bracket since it can equal 3. Okay, let's do some more. Let's do x is less than 4. I'm going to draw it here. I'm going to go ahead and put 0 as a reference point. Put my 4 somewhere around here. Since it can't equal 4, I'm going to leave it open because it can equal 3.999. And it's all numbers less than. So I'm going to shade all numbers that are smaller but very close to 4. So this is going to -infinity. And I write -infinity and 4. It can't equal 4, so I use open interval notation, which is the parentheses. Okay? Let's do this one. We have x is in between 2 and 6, and it's inclusive. It can equal 2 and 6. So all numbers in between 2 and 6, all real numbers. That includes fractions, decimals. So I'm going to draw it. Alright, I'll put 0 over here because we're at 2 and we're going to 6. Since it can equal it, I close it up and I shade in between. So it's all those numbers, including all decimal, fractions, all that. So that's closed interval 2, comma 6, closed interval. That's your interval notation. Alright. Let's do an OR statement. Alright. Let's do the OR. This one, we have x is less than 1 or x is greater than or equal to 5. So I'm going to write this down and kind of draw it. Here's my 0. Here's a 1. I'll put 5 down here. Maybe I should make this a little longer. Okay. So basically, I see the 1 here, so it can't equal it, so I'm just going to do open circle here. I see the 5. I'm going to take that and close it up. So OR means it's going to be less than 1, but not equal to it, so it goes this way. And greater than or equal to, it can equal 5, but that goes bigger. Now when you have an OR statement, that means you have this spot in here. So what we're going to do is take 2 pieces of it. This part is, since we're going to negative infinity here, and we're going to infinity here. Negative infinity, comma 1, open interval, and we're going to use this union sign. You can think of it as unites or union, but we're going to use it like that, and then we're going to do close bracket here for 5, comma, infinity. Okay? This is actually called set theory notation. So the OR, anytime you see OR, especially when you get the probability, that's that sign, union. Alright? This will be very helpful when you get to calculus and you have to see where intervals are increasing and decreasing. Okay? Let's talk about x as any real number. X is any real number. And I'm going to draw that. That means it can be anything. I'm going to put my 0 here, but it's all of this. So just draw the whole thing, put an arrow here. So that's negative infinity to infinity. So your interval notation is just negative infinity to infinity. Alright? Let's do another one. Let's say we have this graph here. We have 0 here, negative 1, and we have a 2. And let's say we have this. So there we go. That goes that. Oh, let me do a different color. Goes that way. And on 2, we have open interval. And we go to infinity here. Alright. So first of all, the interval notation would be, the set notation would be x is less than or equal to negative 1, or x is greater than 2. So Interval notation would be, we're going from negative infinity, this is infinity on this side, negative infinity, comma, negative 1, closed bracket, unites, or union, with 2, and 2 is open intervals, so we're going to do open 2, comma, and then it goes all the way to infinity. Alright, so that's how you would use interval notation. Now let's see if there's any other ones we can do. I think that's good for this. So that's the idea when you're in one dimension of how to do interval notation.